Ya, aku start ah.
Okay.
Assalamualaikum and good morning. I, Muhammad Al-Fatah bin Marpizan, metric number 1618667, and my partner is Muhammad Fakrullah Hazamin, metric number is 163118. Want to present about our topic, which is recent development, application and challenge of OLED. So, for introduction, I separate it to four parts, which is definition of OLED, recent advancement, challenge, and application. What are OLED? OLED are type of display technology that emit light using organic material. Unlike traditional LED, which need backlighting, OLED produce light at the pixel level. This allows for deeper black, high contrast, and more vibrant color. OLED are also ultra-thin, lightweight, and flexible, making them ideal for modern technologies like foldable, rollable, and transparent display. Recent advancement. One major breakthrough is thermally activated delay fluorescence (TADF), which improve energy efficiency by converting waste energy into light. New manufacturing methods like solution processing and printing technology are reducing production costs and allowing mass production. Stable OLEDs made from plastic or polymer instead of glass have led to innovative like foldable smartphones and rollable TVs. Challenge of OLEDs. The challenge of OLED is material degradation over time affects their lifespan. OLEDs are sensitive to moisture and oxygen, which can cause damage. Production costs are still high, making them more expensive than traditional LED display. For application, in consumer electronics, OLED are found in premium smartphones, TV, and wearable. In the automotive industry, OLED are used for dashboard display and interior lighting. Beyond display, OLED lighting solutions are gaining popularity in architecture, medicine, and horticulture due to energy efficiency and design flexibility. Okay, next, we move to the recent advancement of OLED. First, let's talk about TADF. TADF or thermally activated delay fluorescence. The traditional OLED lose energy as heat, but the ADF improve efficiency by converting non-radiative triplet excitons into radiative singlet excitons. This happens because triplet excitons cannot directly emit light due to the spin conservation rule. What is the spin conservation rule? The spin conservation rule is state that during a transition between energy state, the total spin must remain the same. Triplet triplet excitons cannot emit light directly because the transitioning from a triplet state to a singlet state is spin forbidden. The ADF material are designed with small energy gap, which is below 0.1 eV, that allowing the triplet excitons to absorb thermal energy and transition into single excitons. This process, called reverse intersystem crossing (RISC), enables more efficient light emission. Next, next, we have flexible OLED. The traditional OLEDs use rigid material like glass and silicon, but flexible OLED use plastic, metal foil, or polymer film. This make the display bendable, foldable, and even rollable, leading to new applications like foldable smartphone, fitness trackers, and dual screen laptop. It also makes device more durable and lightweight. Lastly, we have QLED, or we known as quantum dot LED. Unlike traditional LED, unlike traditional OLED, which rely on organic compound for light emission, the QLED use tiny semiconductor particle called quantum dots to create more vibrant and precise color. Color emitted depend on the size of quantum dot. Ha. The small quantum dots will produce blue lights. The medium quantum dot will produce green light, and the large quantum dot will produce red light. This technology is widely used in TV, monitors, and laptops to produce sharper and more colorful and high-definition image.
All right. So with that, we covered about the recent development of OLED technology. Now we dive more into the application of OLED in current technology, which is the first one is the automotive lighting. So automotive lighting is where OLED use, which is in smartphone, TVs, and tablets. They are being used for interior lighting and display, dashboard display. Imagine a car interior where the light can be customized to match your mood or the time of day. That kind of innovation OLEDs bring to the table. So, what are the advantages? The advantages are the thickness and white color gamut, which is it can be tunable. We can tune the chromativity and innovative design that enhance both aesthetically and functionality, and fast time response, which is very flexible, and for the self and also the self emission properties. Next. So the next one is display in electronic devices. So OLED is very well-known application in electronic display, which is being used in smartphone, television, wearable devices like smartwatches and fitness tracker. Why? Because the OLED offers superior image quality with deeper black, high contrast ratio, and vibrant color. So the advantages from this application is a customizable design, which is tunable chromativity and flexible panel. Next one. And the last one is the communication devices. OLED is very used in communication devices, particularly in near infrared range, which is NIR. So NIR OLEDs are being explored for use in medical sensor, night vision, and even short-range communication system. For example, in medical field, near OLEDs could be used to create non-invasive sensor that monitor patient health in real time. And in communication OLED could be enhanced visibly light communication VLC system, which is increase the bandwidth and enabling fast data transmission. So from smartphone to car and also in medical devices, OLED are already reshaping the way we interact with technology. It's very quite impressive that OLED are being used in many ways. Like for example, again, which is the medical devices. All right. Now we move on to the several challenges that need to be overcome to fully utilize their capabilities, which is the first one is the efficiency and longevity. One of the greatest challenges is the how we are going to increase the efficiency and the longevity of the OLEDs, especially for the blue limited phosphor in OLED, which less stable than red, and green one, and also it's also affecting overall performance and lifespan of the device. This is major. This is a quite major problem, especially for the application like automotive light, which durability, durability is very crucial for the longevity of using the light. So for now, the researcher are working on the new material and technique to improve the stability of blue emitting phosphor, but this remain ongoing challenge. And then the next one is the environmental concern. This is very quite huge topic because OLED are being used very widely, and the one thing that people are very concerned about the OLEDs is it's their health because they are using the hazardous material such as coal, arsenic, and cadmium, which can pose environmental risks if we not dispose it very carefully. This is very concerning given the growth of demanding of short-term or disposable device. So efforts are being made to improve how can we dispose the OLED or how can we recycle the hazardous material, but still the industry need to find a way to make this happen. And then the third one is the light quality and the stability. Producing high quality white light is another challenge. White OLEDs often experience color shifting over time due to its variation to the emission peak of different chromosphere. This can lead to inconsistent color reproduction, which is a problem for using in display technology. Currently the researcher are finding ways to stabilize the light output and improve the color consistency of the light. So it's remaining as the complex problem and they are trying to solve it. And then the last one is the transparency and large area uniformity. So for this one, transparent OLED or TR OLED have great potential for application like augmented reality display and see-through screen, but the requirement advanced electrode material that combine high transmittance with excellent conductivity is very, very demanding. So to achieve the uniform light distribution, they need to have a high sheet resistance of transparent electron, which is a very significant problem like large area lighting or billboard display. So despite all these challenges, the potential of OLED is very undeniably have a lot. The researchers are still doing their research and innovation, and we can expect some significant improvement in efficiency, durability, and sustainability of the OLEDs for the further future application. Now we move on to the last one, which is the conclusion, which is from here, we know that OLED have revolutionized the modern technology. The application in display, automotive lighting, and communication system are very widely used, especially in display and automotive lighting. And then the advancement in TADF, flexible OLED, and QD OLED have improved efficiency and design flexibility. So the challenges that are remain in developing the OLED is the material degradation, high production costs, and environmental concern, which is we talked earlier that it costs a lot of material to use, and the hazardous material are still being used until today, that we are currently want to find a way to dispose it in a very efficient way. And we want to long lasting the OLED by improving the efficiency, lifespan, and sustainability. For future potential, you can see that OLED is a set to remain a cornerstone of innovation in display and lighting technology, which is we have to wait, and we know that this will affect the future of our generation in the future. I think that's all from me. Thank you.